We are the MOLIBDêNIO team.
My name is Catarina, and I'm responsible for the design, programming, and construction of the sorting hat.
My name is Giovanna, and I am responsible for the big screen programming and the Marauders map software.
My name is Caio, and I'm responsible for the construction and programming of the illusion table. My name is Lucas, and I'm responsible for the construction, mechanic, and programming.
I am Jan. I'm responsible for the boogeyman closest construction, programming, and structural decisions.
The illusion table structure was made using cardboard covered with a layer of resin and fiberglass to provide greater resistance. It was designed to be portable, making it possible to disassemble it and attach it again using Velcro steps. It is divided in 3 floors, containing wonder boards, which place the 2 PCs that will be used in your presentation. They are PCB and a monitor for holography. Each PCB contains a battery to power the monitor and components, input for Arduino Mega ESP32 and Bluetooth modules. On its top floor, there is an acrylic plate placed at 45 degrees fixed by printed support, wrapped in a type of black cardboard box, which allows better visualization of the holography image. As for its software, we used a C++ code in the Arduino that, after receiving a message by serial from the ESP32 cam, resends this message to PC via serial 2. So, holography is performed when beams of light reflect on the acrylic, which works like a mirror, and then come out parallel, producing a virtual image. Because the holography system is an innovative and surprising technology combined with physics, we chose it as a feature.
The human-robot interaction will occur through the spells in which a ESP32 cam recognizes each specific movement performed by the wand. To achieve this, at the tip of each one, there is a high-brightness LED, which is recognized through a color segmentation code in C++ using the camera.
For the audiovisual effects on the big screen and control of messages sent to the robots, we have used the Unity game engine. Unity has an interactive scenario model in 3D in which audiovisual elements will appear according to the stage of the presentation. In this logic, we created a server and client system in 2 programming classes, C# and C++, in which the server, in our case Unity, controls all messages sent and received to its clients, the robots. Unity also will show the Marauders map, and to be able to locate the position of each wizard on stage, we used a webcam integrated with computer vision. We have made a color segmentation Python code with the OpenCV library, in which each person has a characteristic color to represent them. So, after recognizing the color, there is a calculation to obtain the x and y coordinates from the world coordinates. After obtaining them through experiments, there is another calculation to transform the proportions of the camera screen to the Unity screen. These coordinates will be sent via Bluetooth to Unity, which will then position each person's name on the screen based on them, in augmented reality. We choose the augmented reality and computer vision integration as a feature because they bring to us an innovative solution and also are broad technologies.
The closed structure was made following the same logic as the illusion table, using cardboard, resin, fiberglass, and Velcro straps. In it, there is a drawer made from MDF that moves along a track that contains an animatronic robot inside. On the side of the drawer, there are racks that, connected to a DC motor, make the drawers move quickly. The robot's transformations involve a system with a spool attached to a motor that pulls a cape inside, changing its appearance to that of a clown. Taking into account that the boogeyman transformations and movement system is quick and surprising, we have chosen it as a feature. Its PCB contains an Arduino Mega Bluetooth HC05 modules, inputs for motors, ESP32 cam, and voltage converters. A challenge encountered in its production was due to its large size.
The sorting hat structure was constructed with 4 heat-moldable plastic bases to allow dynamic movement to the robot. The hat's movement is divided in 4 different bases, chief among which is the first and second base that provide an opposite movement connected by a hinge. Its PCB has inputs for batteries, Arduino Mega, servo motors, connectors to HASP and Arduino, Bluetooth modules HC05. Its software is divided in 2 parts, the recognition and decision on Raspberry and the movement on Arduino. We have used Edge Impulse to create a keyword spotting system filled with a huge audio dataset in order to train an AI created by us to accurately identify the words answered by the wizard. To achieve this, we have created a code that captures the answers that the AI identified, and based on that, adds differences in each house, and in the end, it analyzes the house with the highest result. The sound that the hat will perform with a speaker connected to it will also be the function of the Raspberry, and after the randomly chosen question, the audio will be activated. As for the movement part, we have based on the most spoken phonemes in the English language, in which we created a code in C++ which analyzes each character of the received sentence, and a specific movement function is called depending on it. Because the integration between hardware and software is very important for the performance of the hat and uses several technologies working in coordination, we chose it as a feature.
The Dub's body structure was made using PVC pipes to use printed parts for the connections of his body and phone. On its MDF base, there are 2 dynamics motors and a free wheel that allow it to move. Its PCB has an Arduino Mega, battery with 12-volt inputs for speakers, Bluetooth modules, ultrasonic and infrared sensors. For its locomotion, use a board that uses image recognition to identify a specific color and the robot walks accordingly.